Okay, let's give you guys some more practice. So in the previous video, we looked at this system. Now we're going to look at a different system. We are going to look at this system here. In this case, we are going to pull the spring down and then release it, and then it's going to do something like this. Okay, so this time we're going to use this as our model. So find the average displacement from 0 to 2 pi. So this is time going along here, displacement, or find the average displacement over this interval, 0 to 2 pi. So press pause and have a go. Okay, so to do this, we need to, well, looking at this, you can see that it spends a lot of time, from here to here, it spends a lot of time in the negative realm. From here to here, it spends quite a lot of time in the positive realm. And then here, you've got a small amount in the negative and maybe in the positive up here. Well, to find the average displacement, find the actual area and then divide it by this distance here, or this time here. So divided by this time here. So work out the area. Work out the area from 0 to 2 pi of this thing here, and then divided by this length here, which is 2 pi, and then that will give you your average displacement. Okay. So to find out this area here, we need to do this. We need to find the integral from 0 to 2 pi. But let's just leave this to the end. Let's just integrate this, and then we will evaluate it from 0 to 2 pi right at the end. Okay. So looking at this, you should be able to by now spot that you should use integration by parts. And the thing is, you will need to use integration by parts several times, because so here you've got a case where it's going to go round and round and round. So you've got to use integration by parts. So using integration by parts several times. So from here, jump to this table here. That will then give you this. And then remember, this will be plus, minus, plus. So the integral will be positive this, and then negative this, and then positive, the last part will be the integral of this thing here, dt. Okay, so anyway, from here, once you've got this table here, it would then take you to here. Okay, so remember, it's plus, minus, plus. The first part will be this, which is this bit here, and then you've got your minus, this bit here. That's this bit here, and then the last part will be plus the integral of this thing here, dt, which is this bit here. Okay, so looking at this here, hang on, let me think. Yeah, so looking at this here, remember we said let I be this thing here. We said let I be this thing here, but then if you look at this here, I is almost, this is almost I, but not quite, because this bit here, you've got a negative and a positive, but the precise I itself up here is positive and negative. Down here we've got negative and positive, so we need to make this adjustment here. So make this adjustment. Well, we want to get this to be exactly the same as I, so we can have I equals blah blah with another I over here, and then we can group the two I's together. Well, we want to get this to be I, to be capital I, but here we've got a negative and a positive. Up here we said I is, well, here we've got a positive and a negative. So make the adjustment on this. So rewrite as this. Hang on, rewrite as this. So this thing here, we can rewrite it as -1 times this thing here, because up here you've got this thing times this thing here. So here we've got this thing. Well, you know that these two will be the same as this. Well, you can write this as this. Okay, and then we this thing here is a negative, is a constant. So take it out. That will then give you this. So now this thing here is precisely capital I. So we can write it as this. We can write I equals blah blah with with a minus here. That's a minus, and this whole thing here is capital I. Capital I. So now add I to both sides. That will then give you this. And then now divide both sides by 2. That will then give you this. And if factorize this, this is in common, this is in common. Factorize it will then give you this. And then negative cos, positive cos, 2 will cancel out. You got sint here, that will give you 2 sint. And then what? And then this times this here, that will then give you this. Well, the integral is given by this. Okay, so now we need to evaluate it from 0 to pi. So we would need to evaluate it from 0 to pi. And then you evaluating from 0 to pi, put this into here and into here. Well, sine of 2 pi is 0. And then later on you put this into here. Sine of 2 pi is also 0. So after all that, oh, I forgot to say, sorry. When you're here, you can take this negative out, and then it boils down to you evaluating this. Well, you evaluating it, it will still give you an area of 0. Well, if the area is 0, then you get the area divided by 2 pi, and then that will then give you your average displacement. Well, because the area is 0, the average displacement will also be 0. Okay, so after all that, the average displacement is actually 0.